Welcome to Edison Open House Future Transport 2021. Now, we've been talking a lot about lithium because it's critical to a future clean economy, and we've showcased a number of lithium companies. In this session, we're going to look at the work of Vulcan. It's an Australian listed company which is in mining development and works mainly in Europe. With me is its Vice President, Vincent Ledoux. Vincent, welcome.
Thank you very much. Hello, Vivian.
Just explain to us, if you would, the different types of ways of getting lithium out of the ground.
Sure. So lithium is the lightest of metal, and it's historically extracted from two different types of deposits. It can be extracted from a typical open pit mine in Australia. So you extract a rock that you then export to China to be refined into a chemical. It's a method which is highly polluting. You're going to be rusting hard rock, use lots of sulfuric acid, lots of heavy chemicals to convert it into a chemical product. So it emits a lot of CO2. The other way to produce lithium is from South America, from large salt flats we call salars, and you'll be extracting a brine, which is basically a salty water. And from this brine, you put it into evaporation plants, and with the sun and the wind, the solution will slowly evaporate, and you'll be able to extract a solution and then treat it with lots of chemicals and lots of water to be able to extract and produce a lithium chemical. In terms of CO2 intensity, it's better than what you do in China, but it's using lots of water in the driest place on Earth.
So neither of these approaches are ideal by any stretch of the imagination. What's Vulcan's approach?
That's correct. So it's kind of defeating the purpose of electric vehicles a bit because it is harmful to the environment. So our idea at Vulcan is to actually use a geothermal brine. So a geothermal brine is already offering you a source of renewable energy because it's a hot brine. You're going to be using the steam coming from this brine to generate electricity, and that's all renewable. But the hot brine also contains a high concentration of lithium, which is unique. You can actually find this combination of lithium concentration and geothermal brine in only two places across the world, in the Salton Sea in California and in the Upper Rhine Valley in Germany, where we are located. So we are combining both renewable energy and lithium production, which allows us to produce a lithium with zero carbon emissions.
Which is an extraordinary achievement. But what are the costs of doing this? And I know lithium, it's going up and up in price all the time, but will there be a good return for investors, and what are the capital expenditure required for this?
Yes, typically your upfront cost, so your capex will be a bit higher than a usual lithium processing plant or lithium mine, and that's because you are not just developing a lithium project, you are developing a renewable energy project and a lithium project at the same time. So you already have two different businesses: renewable energy with a geothermal plants, and a lithium business with an extraction plant and then a refining plant. So the upfront capex is higher. However, running this plant is going to be cheaper than a typical operation in China or in South America. And that's mostly explained by three reasons. The first one is that you don't have to pay for a feedstock. If you are going to be based in China, you need to import the feedstock from Australia via hard rock. And that's going to be expensive. You need 7 to 8 tons of feedstock to produce 1 ton of lithium chemical. That's going to cost you, to start with, already something like $5,000, depending on market prices. For us, the feedstock is coming for free. It's coming from underneath our feet. That's the hot brine. And it's not just coming for free. The feedstock is actually used already to generate revenues through the production of electricity. And then it comes to us. So we actually already generating revenues with the hot brine producing electricity, and then we get it to extract the lithium. So that's the first point. The second point is, if you are going to produce lithium from South America, you'll have to use lots of chemicals to process the brine. For us, we use a physical separation to get the lithium out of a brine. We use a resin. So we don't use lots of chemicals. And so that's also saving us a lot of money. And the last reason is energy. If you are going to be running a conversion plant in China or in South America, you need lots of energy. It's energy intensive. It's energy intensive for us as well, but energy is something we've got plenty of because we are producing our own.
So that's how, as well, you achieve this zero carbon footprint.
Correct. And actually, when you look at the entire process from geothermal energy to dark lithium extraction, all the way to refining this product into a lithium hydroxide or lithium carbonate, we always generate more renewable energy than we consume ourselves. And all along the way, we don't burn any fossil fuel. All the water is being recycled. It's a closed loop operation. And so the entire process, not just from a CO2 perspective, but also from a chemical consumption, water consumption, is extremely sustainable, which is perfectly in line with what automakers and battery makers are looking for, especially in Europe.
And one other particularly attractive feature, I guess, is that it's produced in Europe, because there's a huge concern about the resilience of supply, with most of the supply currently coming from China.
Absolutely. So currently in Europe, we are not producing any lithium. We're not extracting it. We're not converting it. And 80% of lithium hydroxide, which is the type of lithium you'll be using in advanced batteries, is coming, as you said, from China. But in Europe, we are going to become the second largest consumer of lithium chemicals in the world in only a few years' time. Europe is going to become the second largest producer of electric vehicles, of lithium-ion batteries. And within lithium-ion battery, lithium is the only component you can't get rid of. You always have to use lithium. You can get rid of cobalt and other elements, but lithium has to be there. So Europe is going to consume, in less than 10 years' time, by 2030, roughly 800,000 tons of lithium chemicals, which is more than twice the size of a global market today. But we don't produce anything. And more automakers and battery makers realize that the market is going to become more regional. They're going to be buying the batteries in Europe, the cathode-in batteries, but they also need to de-risk the supply chain by sourcing the nickel, the cobalt, and obviously the lithium from Europe as well. And it's also an effort that the European Commission is driving and has been working on alongside with us for a number of years.
Now, it's lithium hydroxide, and the chemistry of batteries may change. The batteries are going through extraordinary, I would say, evolution, but actually it's more like a revolution at the moment. Could you be caught out by the automotive manufacturers going for a different type of battery chemistry?
So we often get the question on, what will happen if the technology changes. It already took more than 20 years for lithium-ion batteries to arrive where they are today, to the capacity they have today, to the cost they have today. It will take probably another 20 years or maybe another 15 years for another technology to completely replace them. And when you look at the investment that have gone into building gigafactories in Europe, they are all for lithium-ion batteries, for nothing else. But then when you start looking inside those batteries, the most, let's say, the priciest component and the most important component within this battery is the cathodes. And that's really what is evolving inside those batteries. And what's evolving is the ratio of battery metals used within those cathodes, how much cobalt you're using, how much nickel you're using. And that will impact the type of lithium required in the battery. For example, a lot of companies want to move away from cobalt. The first reason is because it's associated to child labor in the DRC. The other reason is because when you move away from cobalt and you use more nickel, you also increase the capacity of your battery and therefore the driving range. And it's a good thing for us because we're targeting the production of lithium hydroxide, which is exactly what is used in high nickel content batteries. So in the next few years, for us, the demand is perfectly in line with what we are going to be producing. But one thing to bear in mind is we can adapt. So we are able to start with our own feedstock and to go down different paths of production. So producing lithium carbonate, producing lithium hydroxide, and eventually one day, if we need to produce lithium metal for solid state batteries, for example, this is also something we can consider because we have the feedstock to do that.
Now, you've been working, I know, with another of the companies that we've looked at in this series, Circular, to track and trace, if I can call it that, lithium throughout its life cycle. Tell me a bit more about that partnership.
Absolutely. So Circular is a company who has been involved in tracking raw materials specifically for batteries for a number of years. And it all started really at looking at the supply chain for cobalt, which was always an issue from the very beginning. And they've done an enormous amount of work to be able to track who was working at those mines, how the material was mixing across the supply chain, and what really the end user was going to receive as a finished product that was going to go in the battery. So they have experience of fully tracking, offering a full I guess, traceability and transparency of the supply chain. But we, as Vulcan, would like to implement as well in Europe. But for us, I will say the work is a lot easier. We produce in Germany with very strict regulation, and we are going to be supplying our product to German and European customers in general. So the work of traceability and transparency is pretty straightforward. However, this is still something we want to be able to offer to customers, for them to know exactly when they start driving the cars or when they receive the battery pack, where the lithium has been through since the very extraction of the material all the way down to the final usage. But also what's interesting to look at is how much CO2 has been generated all across the supply chain. And we want to be able to track that from the extraction to the conversion to the refinery and all the way down to the actual electric vehicles, and to show that this lithium is coming from Europe, from Germany, and it has emitted no or negative carbon footprint along the way. And that's the work we're currently working on with Circular. And actually our first demonstration of that will be towards the end of the year, when we produce much larger samples from our demonstration plant in Germany.
I mean, you're inherently in a business which is about, looking towards a net zero future. And that's a very important component of ESG. But this work with Circular is actually also critical, because it's increasingly something that's demanded by investors. And is that what you're finding?
Well, look, absolutely. And I would say it's not just investors who are asking for ESG. It's also automakers themselves. If you look at what they used to look for when buying raw materials, if you were a lithium buyer a few years ago, you'll only be looking for the right volume, the right specification, and the right price. So only those three components were really crucial for you. But now you need to add sustainability and location to this, which are equally as important as the rest. So the environmental impact of a product you're going to buy and where it is actually produced, it needs to be local, is equally as important as price, volume, and specification. And that's something we notice more and more when we talk to automakers. And obviously from the investor's perspective, that's why Vulcan has been doing so well since last year and since the creation of the company, is because we answer perfectly what the market has been asking for, which is, again, a local and stable way of producing lithium.
And of course, it's very handy that when the Earth was being formed and all these geothermal outlets were kind of in process of formation, it happened to be done where the German auto industry is located relatively close by. So that location must be an enormous benefit to you.
It is quite an interesting benefit to have, of course. One thing to bear in mind is that the extraction process will happen in the Upper Rhine Valley, where the very large reservoir is located. But then the transformation will actually be done at an existing chemical park, but it will never be far from the actual deposit. And as you said, I mean, it's basically in the region of Frankfurt and Stuttgart, where a lot of large automakers have their headquarters, but also a number of gigafactories are being built. But at the end of the day, the end product, which is lithium hydroxide, even if it had to be trained or trucked, it's never going to go very far away from where we are producing the lithium.
It's an extraordinary coincidence, isn't it? German manufacturer of cars, your lithium deposits in the same country. I mean, who could want more? So you've talked very compellingly about your future for lithium, but I wonder if, and this is something we've been asking everybody, if you could tell us a little more about what your vision for the future of transport is.
Yeah, of course. So for us, we see, I like to split transport in different categories. The future of passenger cars is, for us, pretty obvious. It's electric and it's driven by lithium-ion batteries, and eventually moving into autonomous. I think for other type of transportation, the future is still a bit mixed. It's hard to know exactly which technology is going to win, especially when you're moving into, let's say, heavier duty vehicles, from trucks to very large transportation modes like trains, etc. There, it is more open in terms of who is going to win: hydrogen, lithium-ion batteries or other solutions to have a more sustainable type of transport. One thing is for sure, sustainability is the word. Whether it's hydrogen or lithium-ion batteries, that remains to be seen. So passenger vehicles and lithium-ion batteries, this is set in stone. For larger vehicles, it remains to be seen. And also for everything which is flying around, planes potentially can be using both hydrogen and lithium-ion batteries. Helicopters and autonomous taxis seems to be using more lithium-ion batteries and solid-state technology. But there's a lot more work to be done on this level. Cars are ready; they're ready to go. They've been ready for a number of years. For heavier duty vehicles, I think it's going to take a bit more time for the industry to really figure out what's best in the future.
So whatever the long-term future, for the immediate future, the future is lithium. And you are extraordinarily well placed at Vulcan for that future. How are you looking forward to the next 10 years as Vulcan? Is it promising for you?
Yes, well, within those 10 years, we have a lot of work to develop the company further, to further de-risk the projects, and to develop our collaboration with automakers and battery makers. In the near term, for us, we are going to be publishing during the summer of this year samples from our pilot plant that are going to be sent to automakers and battery makers for testing. So they're going to be able to have a look at the quality of the product which is coming from Germany. Towards the second half of the year, we're going to be building a much larger demonstration plant, which is going to be producing much larger quantities of lithium, that again is going to be tested by automakers and battery makers. And next year is a big year for us, because that's when we are going to secure the full project financing for phase 1 and for phase 2, which is an important capex and obviously an important step for us. And we're hoping to be able to start construction the following year. And for us, commercial production is looking like starting in 2024 and then ramping up in 2025, 2026, and really reach that full capacity of around 40,000 tons of lithium hydroxide in 2026. And to give you an idea, 40,000 tons of lithium hydroxide is around, you'll be able to support the production of 1 million electric vehicles per year, which is significant. But if you look longer term, our resource is so large that actually, if we want to expand, if you want to be able to support more electric vehicles, we can do that. We have the largest lithium resource in Europe. We're only using a fraction of what's in the ground under our licenses. So if we want to, we just have to build more geothermal plants, more extraction sites, and we are going to be able to ramp up production and supply additional automakers and battery makers in Europe.
It's a hugely exciting future for Vulcan. Thank you for telling us about it, and good luck with it.
Thank you very much, Vivian.